In these tutorials, we are going to talk about the convergence and divergence of a telescoping series. A telescoping series is a type of series where most of the terms cancel each other out, resulting in a simpler sum. In a telescoping series, consecutive terms often have opposite signs or specific patterns that allows cancellation. As a result, the partial sums of a telescoping series have a simplified form. This property makes the series easier to evaluate. So let's look at some of the examples or a typical example of a telescoping series. This is an example of a telescoping series. Summation as n starts from 1 to infinity of a all over n plus b n plus c, where a, b, and c are all at arbitrary constants. This can also be an example of a telescoping series. So this too can be an example of a telescoping series. So the bottom line is, for the telescoping series, the formula in front of the summation sign, it can be simplified or written in terms of partial fraction. That's how you are going to know that the series is a telescoping series. Alright, so let's start with some examples. Let's test whether this series converges or diverges. Summation from n equals 1 to infinity of 1 over n multiplying n plus 1. So we have this series and we are going to test whether it converges or diverges. So without wasting much time, let's resolve the formula in front of the summation sign into partial fractions. So we have 1 over all over n multiplying n plus 1. To resolve this, you can write it as a over n plus b over n plus 1. We are going to have 1 over a multiplying n plus 1 plus bn. So this is just the basic way of resolving into partial fraction. So we can say if n is equal to negative 1, if n equals negative 1, we are going to have a negative 1 plus 1 plus b multiplying negative 1. This part will go to 0, so we are going to have 1 equals negative what? B. And b is going to be equal to negative 1. Right? So we have the value of b. Let's do for a. So if n is equal to what? 0. What are we going to have? 1 equals a multiplying 0 plus 1 equals b times 0. So 1 is equal to a. So our a is 1. So now we have values for our a and our b. So 1 over n multiplying n plus 1 can be rewritten as a, which is what? Our 1 here. So 1 over n, and our b is what? Negative 1. So minus 1 over n plus 1. So the original series, which was summation starting from n equals 1 to infinity of 1 over n multiplying n plus 1, can be rewritten as this: n equals 1 infinity 1 over n minus 1 over n plus 1. So we have the same thing over here. Now let me make some space and start doing the actual work. So this is the resulting series that we had after partial fraction resolution. Had 1 over n minus 1 over n plus 1. So when you have this in a typical telescoping series, what you are going to do is you are going to write down some of the terms, at least up to I usually prefer writing up to the 8th for the 7th term. So when you are done writing some of the terms, then we see what's going to cancel out and what's left. So let's start writing this, or writing some of the terms for this particular series. So starting from here, our first term is going to be when n is equal to 1, we are going to have 1 here. Here is going to give us 1 over 1 plus 1, which is 2. Plus, when n is equal to 2, we are going to have half here minus 1 over 2 plus 1, which is 3. So in that order. So you are going to see a pattern. So we are going to have 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5 plus 1 over 5 minus 1 over 6 plus 1 over 6 minus 1 over 7. In that order. Plus 1 over 7 minus 1 over 8. So like I said earlier on, you are going to see a pattern and you keep writing some of the terms up to the maybe 8th or the 9th or wherever that you think it's good for you. But like I said, I usually prefer writing up to the 8th term. So here we are going to have another term as 1 over 8 minus 1 over 9. Let's keep writing the terms. So here we will write the term up to the last term. So here plus the last term is going to be 1 over n minus 1 over n plus 1. This is going to be the last term. Always for series, the formula of the series resembles the last term. So you write this up to the last term. But usually what we do is we write the last but 2, the last but 1, and the last term. So for you not to get confused, let me write the last term here. So I'm continuing from here. 1 over 8 minus 1 over 9 plus, you are going to have a certain term here. This is the last but 3 term plus, you are going to have the last but 1 term here, and you are going to have the last term here. So obviously our last term is going to be 1 over n minus 1 over n plus 1. And we know that for the last term, if we have this as a last term L, we want to go to the last but 1 term is what? L minus 1. The term that one too is what? L minus 2 in that order. So we are going to apply the same idea here. We're going to apply the same idea to write the last but 2 terms. So here we are going to subtract 1. We are going to write the last but 1 term here. So we are going to subtract 1 from the last term. So we have 1 over n minus 1 over n plus 1. So for 1 over n, we are going to have 1 over n minus 1 minus, and the 1 over n plus 1. We are going to have 1 over n plus 1. We're going to have 1 over n plus 1 minus 1. So it's just going to give us 1 over what? N. And this, the last but 1 term, you are going to use it to write the term that is that particular term in which this comes before it, and that is our last but 2 term. So the same idea, we are going to subtract 1 from it again. But it's more or less like we want to write the last but 2 term. And like I said, the last but 1 term is what? The last term is L. The last but 1 term is L minus 1. So the last but 2 was L minus 2. So here we are going to subtract. You can either subtract n minus 2 from here, or just, yeah, you can either subtract 2 from here or 1 from here. So in either case, you're going to have 1 over n minus 2 minus 1 over n minus 1. So this is what we are going to have. This is what we are going to have. So let me erase this part. We continue from here. Okay, so now we have some of the terms, the last term, the last but one, and the last but two terms. So let's look at, or let's check out the terms that's going to cancel. We explained earlier that for the telescoping series, most of the terms are going to cancel, which makes the derivation of the partial sum very simple. So here we have negative half here. So this negative half is going to cancel out this positive half. This will cancel this. This will take care of this. This, here, there, here, there, here, there. Don't forget that this negative 1 over 9, if we continue writing the ninth term, you're going to have plus. Let's look at it this way. We have this is the eighth term, right? So let's assume that you're writing another term. You cannot write each and every term, but you write up to a certain point, and we do the analysis into the next terms. So here we have the eighth term. So the next term is going to be what? 1 over 9 minus 1 over what? 10. So this negative 1 over 9 will cancel this positive 1 over 9. You have to know that it will keep cancelling each and every term till the terms that are going to what? Be left out. Let me erase this. So everything is going to cancel out. But don't forget that nothing took care of the first one. I mean, this term right here, the one, because there is no negative 1 over here. So we will have that one left. And let's look at this part. We have negative 1 over n plus 1. We're going to maintain this because nothing is going to cancel this out. 1 over n, we have negative 1 over n here. Positive 1 over n minus 1. We have what? Positive 1 over n minus 1 here. So this 1 over n minus 2, is it going to go? Are we going to cancel that out? If yes, why? If not, why not? Now, so let's do the analysis here. We have 1 over n minus 2, right? So let's assume that we are writing for the last but 3 term. We're going to have 1 over n minus 3 and what? 1 over n minus 2. This is the negative 1 over n minus 2, and we have positive what? 1 over n minus 2. So this will cancel that. So that's the analogy. You need to work into some of the hidden terms. So this is going to cancel out. Let me erase and we write out the terms that did not cancel out. Okay. So everything is going to cancel out except, so yeah, we can write the partial sum as Sn equals, we are going to have our 1 here. This term, nothing cancelled this term. Everything else was cancelled up to the what? The last term, that's negative 1 over n plus 1. So this is going to be the what? The partial sum. After we are done writing most of the terms, every term is going to take care of each other. They are going to cancel each other except these two. So when we sum them, even if we sum them up to infinity, like in this question, we are going to have 1 minus 1 over n plus 1. So we now have our partial sum, and we apply the idea that we have. We know that limit as n approaches infinity, the partial sum, we take that limit, and this is equal to what? Limit as n approaches infinity of 1 minus 1 over n plus 1. The space there is too small. Let me write it well over here. We're going to have limit as n approaches infinity of the partial sum, which is 1 minus 1 over n plus 1. So as n approaches what? Infinity. 1 over n plus 1 will approach what? 0, because we have 1 over a very large value plus 1. So 1 being divided by this value, we are going to have 0. So at the end of the day, our, let me make space somewhere here. At the end of the day, our partial sum is going to be limit as n approaches infinity. Our partial sum is going to give us what? Definite value, which is 1, because the whole of this part is going to go towards 0. So we are going to have 1. Like we said in the earlier videos, if limit as n approaches infinity, the partial sum is equal to a finite value, then the series what? Converges. So we can confirm that this is what? A convergent series.